So today we will be discussing on few of these named reactions: Aldol and Benzoin condensation, Knoevenagel condensation, Claisan-Schmidt reaction, Parkin's reaction, etc. Okay, after this we will do today. However, we have several named reactions. Let us see the first one. Aldol condensation. As you know, what is aldol condensation? Aldol condensation is a addition of two ketonic or aldehydic compound, okay, where the first necessary thing that is required is it should have a alpha hydrogen. Okay, so if the compound is not having a alpha means the functional group, and adjacent to the functional group, the carbon that is bonded is called alpha carbon, and that particular carbon should have hydrogen. That is the first point. And after the addition of two molecules, here it is written one, so you have to understand it is there are two molecules, and these two molecules are adding together to form an aldol. What is an aldol? Aldol is what in the beta position there will be an alcoholic group. This is the alpha position, and there will be a ketonic group. So ketonic group, beta hydroxy ketone is actually what is called a aldol. Ald means you can say aldehyde, and all means alcohol. So from this particular molecule, when one water molecule means this H and this OH moves away as water molecule forming a double bond, we call it as aldol condensation. So this is the condensed product, and water, as in any kind of condensation, water formation is a mass, so water is leaving out of it. Okay, so therefore what we get here is the product is alpha beta unsaturated carbonyl compounds. Let us first see the first step, that is the aldol addition. In the first step, it can be both a base catalyzed, also it can work in presence of acid. Let us first see the base catalyzed, means base will be the catalyst. So the base first takes one H from the alpha position and gives a carbon anion. This carbon anion can resonate with the carbonyl compound, so therefore it is stable. Now this negative charge on the carbon can attack the carbon of the other group, other carbonyl compound. So I said there are two molecules. So first molecule, one H has been removed from this and forming a carbon anion, and carbon anion is stable because of the resonance. Now this carbon anion attacks the other carbon, other aldehydic carbon or the ketonic carbon, and attacks on the carbon that is bonded to the oxygen, because it is having here an electronegativity difference, and therefore this carbon is positively charged and this oxygen is negatively charged. So therefore what you get is this one, and from this anion, this anion will abstract one H from the water, okay, and water molecule, and we will get beta hydroxy ketone. Okay, so from this also can be done in presence of acid. In presence of acid, the lone pairs on oxygen abstracts this proton and gets protonated, and with that the leaving of the alpha hydrogen, the hydrogen that is bonded to the alpha carbon, so it leaves and we get a carbon double bond. Now this carbon double bond again breaks when the lone pair of the oxygen takes part and it attacks the carbon of the other molecule. Means there are several such molecules, okay, you have to understand. So it's not that only one molecule of carbonyl compound is getting protonated, there are several. So in that several, one of this is attacking the other, and then what we get is the addition of these two products. Okay, so what you get here is this is the first step, protonation. This is again the same step happening on the other molecule, and this two finally combines together to give you the final product, and the removal of proton finally leads to the beta hydroxy ketone. Now, after getting this beta hydroxy ketone, what we will see is the condensation, means formation of water molecule. Now, it can also happen in two ways: base catalyzed, and also it can give us the product as acid catalyzed. Let us see the base catalyzed. Now, in case of base catalyzed, the alpha position hydrogen will be taken up by the base, and we will get a double bond and leaving the OH group. In case of acid catalyzed, the water hydroxy group will get protonated, and it will leaving a proton as well. So we are getting here the same product, that is alpha beta unsaturated carbonyl compound. Let us see the next one here, the benzoin condensation. So you have to understand what is benzoin. Benzoin means similarly it is not beta hydroxy, it is alpha hydroxy, you can say a aromatic aldehyde. So what is benzoin? Benzoin condensation is the coupling reaction between two aldehydes that allows the preparation of alpha hydroxy ketone. Okay. So the first method here, so you have to take an aromatic aldehyde, that is a benzaldehyde, okay, and finally what you see here you will not get any alpha hydrogen. This alpha position is not having any hydrogen. So if you count 1, 2, 3, 4, so there is no hydrogen in this alpha position, and therefore what you have is this is an aromatic aldehyde. So let us see the mechanism, how the mechanism works. Here Cn minus is the initiator. So cyanohydrine, that is formed. Okay. So addition of cyanide ion takes place here. Cyanide ion attacks the carbon, and finally what you see here is cyanohydrine is formed. So how this hydrogen will be formed? It will be abstracting one proton, and we will get cyanohydrine. Now from this cyanohydrine, another base will take part and abstract one of the proton. Now this proton abstraction leads to carbon anion, and it is very much stable as it is resonating resonating within the ring. Now when it is resonating within the ring, what happens is that this negative charge is stable, and this will attack the another benzaldehyde, and it will attack the carbonyl carbon. Okay, so finally what we are getting is a O minus, and this will take a proton from the water and give us the product. And this is not the final product. From here another step will happen, and this cyanide will leave. How this happens? This base will abstract the proton. This will lead to a formation of a carbon-carbon double bond, leaving this Cn as Cn minus. So finally what we get is alpha hydroxy. So let us see the next reaction, Knoevenagel reaction. Condensation. So here also whenever there is a word condensation, we know there will be a formation of condensation of one product. Okay, so normally it is water. Okay, so let us see this. Here what we have taken is condensation of carbon acid compound with aldehyde. So we have what? We have a carbon acid compound, ester, diester, you can say. This is an ester, this is an ester. So it's a diester with alpha position in between. There should be a hydrogen. Okay, if it is it is not having this hydrogen, this reaction will not occur, and it will condense with another different molecule, that is it is an aldehyde. Okay, so in presence of what we call is tet 1, 2, 3, 4 pentahydride pyrrole, pyridine, sorry, pyridine. So here we have this is the condensed product, addition product, and after this what we see is this heat is there, and with this there is another molecule of pyridine. Okay, pyridine, and this pyridine will form two molecules. One is the same is coming out and we are getting an acid. Okay, so here the compound that is forming is alpha beta unsaturated compound, that is an acid. So this is an acid and this is the alpha beta unsaturated product. Okay, let us see the mechanism. So first step is an enol intermediate is formed initially. So the pentahydrated pyrrole will be pentahydrated pyridine will be abstracting one hydrogen because of the presence of lone pair, and this lone pair will take this proton and give a negatively charged species. This negatively charged species is resonance stabilized. So after this, what happens? It will react with the aldehyde. Okay, this negative charge will react with the negative carbon of the aldehyde, and we will get an oxide. So this oxide again will abstract the proton of the base, protonated base, and we will get one alcohol. So from this alcohol, one H will be abstracted by the base again, and this will give us the alpha beta unsaturated product. So finally, this is the product. Okay, this is the product, is alpha beta unsaturated ester. So further steps may be done or may not be done. So however, this is our product. What is the product? Product is alpha beta unsaturated product. Okay, but it is just an extension. You may delete this part. Okay, it may not be required. So let us see the next part. Next is Claisan-Schmidt condensation. In case of Claisan-Schmidt condensation, also we have the requirement of one alpha hydrogen and carbonyl product compound, and we have an aldehyde. So here you have to remember all this, and their base or acid both can take part. If it is base catalyzed, it takes one proton from the alpha position and gives a oxide. This oxide again will attack the aldehyde, and the addition will happen. The oxide will abstract the proton from water and give us alcohol. See this from here, it is this step. So it is an alcohol. So from this alcohol, what we can do is this can leave one water molecule. Okay, so this can leave one water molecule. How it will leave? First, it will abstract one proton and then giving a negative charge. This negative charge is resonance stabilized. So this is what is resonance. So these two are resonating, and once these two are resonating, this will come out. And this will again come back to its original position. This will come to the next carbon bond, and the OH will leave as OH minus. If it is base acid catalyzed, what is the mechanism? See this. So you can do this acid catalyzed with an acid. In the acid catalyzed, this lone pair will take one proton, and accordingly things will proceed. You can see you can do the mechanism on your own and just see whether it happens or not. Parkin's reaction. In case of Parkin's reaction, what we again take is an benzaldehyde, and it attacks an acid anhydride. Okay, so how is the mechanism? The mechanism is, here we have taken a sodium acetate. See this, here it is sodium acetate. So acetate structure, if you remember, CH3 COO minus. So this is CH3 COO minus. So this acetate will take one proton from the alpha position, and it will give a negative charge. So this is what you are getting is acetic acid. Now from this negative charge will again come back to its original position, that is on the carbon, and the carbon negatively charged will attack the benzaldehyde carbonyl carbon. Okay, so here we are getting an oxide. This oxide will